Hey everybody, it's Mr. Carr again. Today we're going to be looking at 5-4 day 2. In this one, we're going to continue with our sum and difference identities, and we're going to look at a couple different other scenarios. So for our first one today, we're going to look at find the exact value of the sine of the arc sine of 1/3 minus the arc cosine of -3/5. Thing to remember about this is technically what I'm doing is I'm representing my alpha minus beta here. Okay. So since that's alpha minus beta, I got to figure out what are those degrees. Well, actually, no, I don't need those degrees. I didn't, sorry. I need to model those triangles on there because if I'm looking at the arc sine of 1/3, since this is just a different way of saying like what my alpha is, I'm going to go ahead and draw that out and see what it looks like. So that's opposite over hypotenuse. So it's going to look something like this. So I'm going to have one right here. Don't like that one. Let's go right there. Come on now. Okay, 1 and 3. Our cosine of -3/5. So remember where cosine is negative. It's negative in the second quadrant. So because of that, I'm going to have adjacent over hypotenuse as 3/5. So it's going to look something like this. Okay, 3 and then 5. So these are my reference angles. This is beta right here, and then this is alpha. So what I need to do is I need a little bit more information because when I evaluate this, taking sine of alpha, which I do know it's 1/3, but I'm also going to need the sine of beta. So that means I need to know this side right here. Same thing with cosines. The cosine of beta I have, but I need to find the cosine of alpha. So I need to find this side here. So we can do our Pythagorean theorem real quick. I've got 1 squared is equal to, we'll just call it x here. So x squared plus, darn it, 1 squared plus x squared is equal to 3 squared. So 1 plus x squared is equal to 9. Subtract that over, I get x squared equals 8. And then I square root to get x equals to 2 root 2. Okay. Over here, that's my Pythagorean triple. So that's a 3, 4, 5. So I don't have to do Pythagorean theorem in this one. So now I have everything I need to do this. So my sine of, in this case, alpha minus beta, because I don't want to rewrite arc sine of all that. So we got sine of alpha, which is going to be my 1/3. Cosine of beta is -3/5. Those are the two that were given right away. Minus the sine of beta. So sine of beta is right here. So sine is going to be positive in this quadrant. That's going to be opposite over hypotenuse. So that's 4/5. And then times the cosine of alpha. And cosine is going to be 2 root 2 is my adjacent over the hypotenuse 3. Okay. So now it's just a matter of multiplying through and simplifying as best as I can. So for example, here I've got 1/3 times a -3. Normally I would cancel out the 3's, but in this case, because I've got 5 times 3 over here, they'll turn into 15. I'm just going to leave it that way. So this will be -3 over 15. Over here will be 4 times this 2. It's going to give me a 8 root 2 over 15. Just put them together as one fraction so that this equals -3 minus 8 radical 2 all over 15. Okay? All right. Verifying identities. So this is an identity we've talked about in the past. Okay, this is just the idea that for complementary angles, cosine and sine are going to be the same idea. So let's talk about this in terms of those subtractions there. Let's see what it looks like. So if we want to use this, we're doing cosine, the difference of the cosine, difference of the cosine, difference of cosine identity here. Okay, so the only one I need to model is pi over 2. So pi over 2 is my beta, which puts me right here, 0, 1. Okay. So just in case you, okay, 0, 1 is right there. So that's my pi over 2. So now I actually have everything I need. So my alpha is going to be theta here. And then beta is the pi over 2. So the cosine of theta minus pi over 2 is going to equal to cosine of alpha. So in this case, alpha is just a theta. So I'm just going to leave that as cosine theta times the cosine of beta. So the cosine of beta is 0. Okay, so that's going to be multiplied by 0 here. The sine of alpha, so in this case, it'll be sine theta, because that's my first location there, times the sine of beta. So that sine of beta is 1. So 0 is going to just cancel that out. What I'm left with is that cosine of theta minus pi over 2 just equals sine of theta. Okay, and that's it. We just proved something that seems like common sense from before, but Sometimes that's what happens with proofs. We're just showing something is absolutely true. Okay. All right, solving trigonometric equations. These are going to be a little bit tricky. Okay, so we've got multiple identities going on at the same time. We're going to have to use both of those in like two different triangles. Or no, sorry, just one triangle. We're just going to model our our pi over 4 here. Okay, so pi over 4 looks like this. Put it, okay, in the first quadrant. Okay, 1 root 2. Okay, so what we want to solve for is sine of x plus pi over 4 minus sine of x minus pi over 4 equals 0, specifically on the interval of 0 to 2 pi. It's going to be complicated. So we're going to put these together. So here's my two identities for the sum and the difference. We're going to put this minus this is what it's going to boil down to. So what I'm going to have is the sine of alpha, which is x, times the cosine of pi over 4, plus the sine of pi over 4 times the cosine of x minus this whole thing I'll put in parentheses here. Let's be the sine of alpha, so it'll be sine of x, cosine of pi over 4, minus the sine of pi over 4 times the cosine of x, and that whole thing equals 0. All right, so we start substituting where we can. Remember, cosine of pi over 4 is root 2 over 2. So what this turns into is sine of x times root 2 over 2. This one, sine of pi over 4 is also root 2 over 2. So that'll be root 2 over 2 times the cosine of x. Here we're going to have minus this right here. So it's going to be minus, same thing as over here. Sine of x times root 2 over 2. Since it's subtracting a negative, this now turns into a positive. That'll be root 2 over 2 times the cosine of x. Okay, so when we put these together, notice how this matches up to that. We're just subtracting them out. So that goes away. Okay, for the other parts, I'm going to go ahead and add these two together. Okay, so if I do that, I've got root 2 over 2 plus root 2 over 2. So what I get is 2 root 2 over 2 times the cosine of x will equal to 0. Well, make this a little bit easier on myself. I can just modify that a little bit here. So I cancel out the 2's. Then I'm going to divide both sides by the square root of 2. So I get cosine of x equals to 0. This is just like we've done in the past with our solving. When does cosine equal to 0 on the interval 0 to 2 pi? Okay, so if I model that real quick, cosine equals 0 at two locations. It happens right here and right here, 0, 1, and 0, negative 1. So this one is pi over 2, and then this is 3 pi over 2. So again, very specifically, I want to put this into between 0 and 2 pi. So my answers for x are pi over 2 and 3 pi over 2. So it's both of them for my two answers there. Okay, and that is it for today. So again, just a little bit more working with solving, some other evaluations that we're going through. But bottom line is we're still working with those sum and difference identities. So we're just looking for, sometimes we're looking for angles, how we can split them up, or we're dealing with ones that are already given to us like that. All right, that's it for today. Take care, everyone.